Hey, welcome to another adventure in old code. Today we're going to look at something called math, which is of course mine, and it is in the good math folder. So let's have a look at this. Wow, there are a lot of subroutines. All right. B1, B2, AT, D, M, or F. Okay, I know what this is asking me. And okay, let's say V2. Do you have V1? Yes. Do you have A? Yes. Do you have T? Yes. Do you have D? No. Do you have V1? Oh, what is the V1? The V1 is 5. What is the A? It's 2. And what is the T? 6. V2 equals 17. You're done. Now, what in the world is this? Okay, I don't know if we have any... There's no explanation in this code. So, oh gosh. All right, so what the explanation is, this I wrote in grade 11 after taking a unit about kinematic equations in physics. And so kinematic equations are equations defining, not sure why F is there, movement, motion. And so there are different ways of calculating this. V1 is your initial velocity. V2 is your final velocity. A, acceleration. T is time. D is distance. M must be mass. And F is force. That's curious why F and M are in there. Anyway, so there's three ways. We learned three equations called kinematic equations that can properly calculate these things. So based on whichever thing you're needing to figure out, you find one of the equations and you plug in your variables and you're done. So the equations, let's see if I can remember them. V2 equals V1 plus AT. V2 squared equals V1 squared plus 2AD. And D equals V1T plus 1/2 AT squared. And of course, F equals MA. So, so based on, on a test or something, you'd be given, here are a bunch of values. What is this missing value? And you'd have to recognize which of these equations that you're going to use, the three kinematic equations, and I guess for some reason I've thrown F equals MA in there, which I guess it does belong because it does have something to do with motion. And so that is, yeah, I would have written this program to determine all this. So let's go M. I want to find M. Okay, so it's smart enough to not go through all the list. What is the F? The force was 10. What is the A? 5. Mass is 2. Okay. So F equals MA is programmed into here. It's just it doesn't give you any options because there's only F equals MA for that. There's only one way to find out M. So if I wanted to say F, what is the M? Well, it's 6. What is the A? 1.8 meters per second squared. And so it multiplies them together and you're fine. Okay, what about, let's try and find D. Now, D, you can use the V2 squared equals V1 squared plus 2AD, or you can use D equals V1T plus 1/2 AT squared. Yes, I have committed these all to memory. And Yes, I remind myself every now and then what they are, but they're pretty ingrained in there, so I don't think I'll soon forget them. It's been 20 years actually since I was in grade 11, and I still remember them. So okay, do I have V1? Yes. No. Yes. Yes. So what is the V1? 5. What is the A? It's 2. What is the T? It's 8. And D is 104. Okay. So now, how in the world did I do all this? There are so many subroutines. Anyway. Okay, dimjar var, V2, V1, A, T, D, F, M, all as strings. Why are they all strings? That is a very dumb thing to do. Sorry, there's a drummer in the background across the street who's drumming, and it's the dead of winter here, and I still hear him, even though everyone's windows are closed. Okay, clearing the screen. Ask which variable we are interested in. So, oh man, yikes. So if you're interested in V1, we have to figure out, do you have V2, A, T, or D? So it looks like if you have a V2 and A and T, that's a pretty straightforward calculation. V2, A, and D is another way you can find V1. Yep. And if you had T, A, and D, you could also find V1. And those are the 3 different ways of finding V1. Oh my goodness. So if I went into these, oh, and I've put a comment. This is how we're figuring out V1. So V2 equals V1 plus AT, but we're asking for V1. We have the others. So what we actually have to do is, like we all learned in grade 10, we have to bring everything to the other side. This becomes V2 minus V1 equals AT. And then minus V1 equals AT minus V2. Maybe I should have, whoops, that's an equal sign. So V1 equals V2 minus AT. Just multiplying both sides by -1. So that's from this formula, we can rearrange things so that we can calculate V1. V2 is V2 num, A num, T num. There we go. V2 minus A times T. Okay, I'm not going to get into kinematic equations and why this is true. Basically, well, I guess I am about to. Basically, your resulting velocity is what you started at, and then your acceleration, you have to add to your initial velocity your acceleration times the number of seconds you're going to accelerate. And that, so if you start at 10 meters per second and you accelerate 5 meters per second every second, then you can calculate how fast you're traveling after 15 seconds of going that acceleration. Anyhow, okay. The curious thing is, oh, I was like, why are they all strings? Of course they're all strings. Wait a second. No, they're not all strings. Oh, come on. Okay. I'm not using this as a number, that's why. So V2 is a string, and it's going to hold a yes or a no. a y or n. That's why. Do you have it? Answer is yes. Okay. All right. If you want to find out and that was only the way to calculate it the first way. So this is the second way. You could actually use the v2 squared equals v1 squared plus 2ad. So this you have to do a few different things here. You have to isolate v1 squared. So you can say v2 squared minus 2ad equals v1 squared. Bring that 2ad over to the other side. And then you can take the square root of the whole stinking mess. So the square root of v2 squared minus 2ad equals the square root of v1 squared, which is just v1. And yes, it's also minus v1, but a negative initial velocity doesn't matter in this case. Because we're only interested in the positive one. Anyway, so that's, yeah, and that certainly matches this. So this, we've never seen the square root function, but that's how it works. SQR, and then it's the square root of whatever's in the brackets. Okay. All right. Yeah. Oh, there's so many of these. We won't go through them all. If you want A, you can do a few things. You can use the kinematic equations, or you can get A if you have the force and the mass. So that's curious. What if I had the D and the T and the V1? The D, the T, and the V1. This would be the most complicated one, because this equals D equals V1T plus 1/2 AT squared. So to actually figure out the acceleration by doing this, you'd have to go, yeah, you'd have to go D minus V1T equals 0.5 AT squared. And I had to do this to write this program. Then you have to divide it by 0.5 by both sides, which is multiplying it by 2. V1T equals AT squared. Then you have to divide it by A, so 2 times D minus V1T, all divided by A, equals T squared. And then you can take the square root of all of this. No, you can't. I'm calculating A. I'm going to divide by T squared. So, is that right? Did I calculate it wrong? D minus V1T. Oh, I divided by 0.5, and here I'm multiplying by 2. So yeah, it's equivalent. Anyway, yeah, had to rearrange them. But that's what I was doing in school anyway, so I thought, why the heck not? I'm just going to do them all. So anyway, and this keeps going and keeps going. If you're looking for M, there's only one way to calculate the mass, and that's if you have F and A. So what happens if I, let's say I wanted to do V2, but I say, no, I don't have V1, and no, I don't have A. Yes, I have the T, but I don't have the D. You can't figure it out. You cannot figure it out with just that little information. Anyway, that's math. Not the most fun program to go through. But it's all right. I mean, it was a lot of fun to write. So there's actually 4 ways to get T and 4 ways to get D. Woohoo. Woohoo for that. Okay, there's nothing else I can do other than to describe each of the kinematic equations and work them out for each variable that you're trying to find, and then actually explaining them, which I'm not going to do. So this is where I'll stop this program because it doesn't present well. But it was something that I put a lot of effort into, as I hope you can understand, and that's why it ended up in the good folder. So there is a Math 2. I can't quite recall what that is, but I'm sure it's better than this one. So thanks for joining me in this adventure in old code. Have a nice day, and we will see you next time.